everyone. Welcome to the sixth edition of the Prisma Meetup, where we connect engineers from around the globe and learn about databases, best practices, the Prisma Inside Scoop, and examples of Prisma in production. I'm your host, Alex, and we have some pretty exciting talks for you today. At first, we'll have Facundo, who will present on securing your Next.js and Prisma app with Auth0. After that, we'll have Jim Walker, who will talk about the architecture of distributed SQL, and Martina and Nilu from the Prisma team, who will give a fun talk about writing and building the Prisma documentation. So we also have a raffle prepared for you today. To participate, simply enter your name in the type form that we'll be posting in the chat. You get a chance to win a copy of Designing Data-Intensive Applications book by Martin Kleppmann. We'll announce the winner at the end of the meetup. So, sorry about that. So yeah, so let's get started. Before we start with the presentations, we prepared a small survey to get to understand you better. To participate, you can scan the QR code or enter the link in your browser. The results will be shown real time, so participate, and we'd like to understand you better. So I'll give you a couple more moments so that you can sign up. Hopefully we'll be able to see your responses. Okay, awesome. So first question, which mostly describes your work? Do you do more front end, the back end, full stack, or are you a mobile developer? I'll give you a couple moments to fill out your responses. Personally, I'm more of a full stack developer. However, having dived into front end, developer relations, it's more of a mix of both. So, and I don't get the chance to fully dive into one. However, I will soon, but I'd like to know about you, our audience. Yes. Awesome. So one backend developer, one front-end developer. Oh, one full stack developer. That's equal. Let's see if there'll be a mobile developer in our audience. Is anyone out there? The link to the poll is in the. We'll post it. Sorry, let me post the link to the Slido. Okay, let's move on to. Oh, we have a few more responses. Have more full stack developers in our audience. Awesome. So let's move on to the next question. How many years of experience do you have? Is it 1 or 2, 3 to 4, 5 to 6, or 7? I think I started coding sometime in 2017, looking to build a game. However, I've never built any so far. I got lost in front-end development. Yes. Awesome. So we have some pretty experienced engineers in our audience. Awesome, thanks. And lastly, what technologies do you use in your stack? This could be literally anything from React, Prisma, Cockroach, DB, Next.js, Vue, anything. Rust, let us know. Ooh, Prisma. Prisma seems to be strong within our audience. I also see, and also React. We have some Rust developers, JavaScript, Blitz, React Native, MongoDB, Node.js, Swift, UI. I'm not so sure what UI specifically means, but I'll assume it's front end. GraphQL, and the cloud. What cloud keeps getting bigger. Awesome. Thank you for your participation. I would now like to introduce our first speaker for today, Facundo Giuliani. He is a systems engineer from Buenos Aires. I hope I pronounced the name of the city right, in Argentina, with over 15 years of experience in software development. He's a full stack developer, an Auth0 ambassador, Git ambassador, Cloudinary media expert, and also an open source contributor. One minor thing to add that was not in the slides is that he is also a Prisma ambassador. Hopefully he will get to tell you more about that during the presentation. Awesome. So I'd like, without any further delay, I bring you Facundo.
Thank you very much. Thank you very much for the presentation and for the opportunity of giving this talk. Well, let me share my screen and we can start.
Awesome. Cool. I see yours prepared, so I hope you're ready.
I am.
Yes, cool.
Perfect. So again, thank you for the opportunity. And today we will talk a little bit about authentication and authorization using a platform, Auth0, and how we can use it and link it with Prisma and Next.js in our web application. First of all, I want to present myself. I'm Facundo Giuliani. I'm from Buenos Aires, Argentina. I'm a new developer relations engineer at Storyblok. Yesterday was my first day. But I'm also a full stack developer. I'm an Auth0 ambassador. I'm a Cloudinary media developer expert. Cloudinary is a platform to handle images and videos. I'm a Git ambassador. Git is a Git user interface application. And I was newly selected as a Prisma ambassador, so this is a great honor to me to share this with a lot of people and Prisma experts. So this is kind of great, and it's new. So hoping to see what the future brings to this. If you want to contact me, my website is fgiuliani.com. My Twitter handle is Facundo Zurdo, and my GitHub handle is fgiuliani. So let's start. First of all, I wanted to give like a formal definition of what authentication is. It is the action of validating that users are who they claim to be, implementing a credential systems, like it can be a user and password combination, security questions, or even facial recognition. So here what we are doing is, if someone is using our application, that we are verifying that the person that is browsing our website or our web application is who he claims to be or she claims to be. And authorization, on the other hand, is the action of determining what a user can or can't do. So we will have an initial page in our web application, let's say, where we can put a user and a password to say, okay, I'm this user, I'm Facundo. And on the other hand, we will have different tasks or actions that we can do in our web application. And depending on the role or the, authorization level that a user has, we will authorize or not or disable features from our web application. So that's mainly the difference between authentication and authorization. In this case, we will talk about Auth0, which is a flexible drop-in solution to add authentication and authorization services to our applications. So we can create a security platform for a web application and program everything and take care of all the details that handle the security of our application. But the thing is that it is complicated to do something from the ground and reinvent the wheel, creating a security platform. And on the other hand, we have services like Auth0 that are provided and that we can use only connecting to an API or to the service itself. And we don't have to worry about the maintenance of the platform or how to implement the authentication or the details of how it is implemented or how to secure the data that we are storing related to the user's database that we are handling. So giving that, let's say, responsibility to a third-party service or an external organization makes us not to worry about how we are implementing the security platform and don't spend time on that and spend that time on something that gives more value for our web applications. And on the other hand, we have security experts that are working every day to keep this platform as secure as possible and adding features and adding behavior and well, maintaining all the platform working, so we don't have to worry about that. Auth0 in particular has some features, some benefits. We have a single sign-on service that we can use, a universal login, let's say, that if we use that in our web applications, we allow the users to log in or to create an account in Auth0 platform, and that user can be reused or shared between different applications that use Auth0 as a service. So for instance, if I'm logged in one application using Auth0 and my user and password combination, and I enter to another application that uses Auth0, I don't have to log in again. I will be already logged in. That's one of the features or one of the authentication modes that we have. It's not that that's the only one. But on the other hand, we will have social logins. If we want to log in using Facebook or a Google account, we can do that with Auth0. Another authentication mode is a multi-factor authentication in case we want to implement that. We have different standard protocols that we can use for the security of our web applications like OAuth or JWT. And we will have tools that we can use for reporting and analytics in the Auth0 control panel. What is cool is that we can connect to the tool, to the service, using any programming language or technology. Well, not any, but a lot of them, and we will see that. But we can create a web application using PHP, Node.js, or front-end frameworks like React or Next.js, and connect to Auth0 using their API or some SDKs that are available. And what is cool is that we have a free plan up to 7,000 monthly users that we can use without paying anything and without even configuring a credit card or anything. So that's very cool. As I mentioned before, we will have different libraries and we can use different programming languages and connect to Auth0, like single page applications using backend programming languages, front-end frameworks, or mobile applications. And we have SDKs to be used with all of those tools or programming languages, what will make the way of connecting to Auth0 way easier. You can go to that URL. I will share the URLs after the presentation. But if you go there, you can see a list of programming languages and the SDKs for them. Today, we will talk about one specific SDK, which is the Next.js SDK. You can download it and use it in your application from Node Package Manager using npm, and the name of the package is what is in the bottom of the slide, auth0/nextjs -auth0. And well, if you in this presentation, I will assume that you know what Next.js is. If you don't know about Next.js, it's a framework that is built on top of React and that you can use to create not only user interfaces, but to create pages using server-side rendering, or generate static sites at build time, or incremental static generation. And well, it's cool because it's a framework that, using the same tools that React offers, we can create a web application working on the backend and on the front end. And well, if you want to talk about Next.js, we can chat later, but I will assume that you are at least familiar with a little bit of how Next.js works. But using this package, we will have to configure some details in our environmental file, or our environmental in the hosting service that we are using. And using these environmental variables, using these exact same names, will facilitate us to generate all the authentication for our web application without having to program anything. You will see that, and later we will see an example. But if you set this secret, which is a random 32 characters string that you can generate, a base URL, which is the home page of your web application, an issue base URL, which is a domain that is generated by auth0. I will show you that later. And a client ID and a secret to connect to the auth0 tenant, to the auth0 application that is generated by auth0 But if you configure these environmental variables and you create one file in this root, in this folder, pages, API, auth, and that name with auth0 into the brackets, .js. If you know about Next.js, that is a dynamic root, which means that it can change the slug that we are using to browse that page. But inside the API folder, we will have all the API roots of our web applications, which are the serverless function, let's say. And if we use, if we create a folder called auth, and inside that folder we create this file, auth0 SDK will auto-generate all the logic that we need to handle the authentication of our web application, because we will start to support these 4 roots in our web application that we can use, and we won't have to program anything for them. API auth login will be used to log in a user, and that will display the login box to insert the user and the password. API auth logout will log out the user from our web application. Callback is a callback URL that we will define in auth0 control panel. So whenever a user login in our web application, the callback URL will be the URL where we are redirecting the user after the login action. And API auth me is like a control panel that displays all the user information that we can use, again, without programming anything. This will be dynamically generated by auth0 SDK. So let's see a quick demo about a web application that uses auth0 SDK, and let's see how we can link that with Prisma to store information related to the users that we handle in auth0 authentication platform, and save that in our database and link that to other data that we are handling. So let me, well, this is the application. First of all, I want to show you how the application works. This is an application where users can log in and create accounts. And when they are logged in, they can subscribe to courses that have lessons, that are videos, YouTube videos that you can watch. But the thing is, we have the courses available, but a user has to acquire these courses and the lessons. We are not handling money here. We are not going to use any payment platform. But the idea would be that, I mean, like you are purchasing a course and you have all the lessons available. I didn't want to get into deep with the payment information, but for instance, if you go to this course here, I'm already logged in, so let's do the complete example. So here is the page. We have all these courses list and a login button. I will click on login here, and we will have the login box, so we can log in using Auth0. You can see the logo here. And we can sign up and create an account, or if we already have a login or already have a user, we can log in with it. What I will use.
Hi, Facundo. Sorry for interrupting. Could you kindly zoom in a little?
For sure.
Zoom in a little.
For sure.
Yeah. Awesome. Thanks.
Sorry. So this is the login box. You can put the user and your password. You can create a new account if you don't have one. All of this is provided by Auth0. I didn't have to create this page or to program this page. It's all provided by Auth0, even though I can create my custom login page, but that's something that if you want to research and investigate, you are invited to do that. This is a simple example that I want to show. But I will log in using a Google account that I already have. I will select one of my Google accounts. And after login in Auth0, I'm redirecting to the callback URL that I defined in Auth0 platform that I will show you later. And now if you see here the page, instead of having a login link at the top right corner, I have a logout, which is the one that I used before, a dashboard link that it didn't appear when I was not logged in. This dashboard will display all the courses that I already acquired. And here I can go to this course, let's say, that has a list of lessons. And if I go to this lesson, as I didn't get the course before, I will have a get course button. I will click it, and I'm redirecting to a success page that says that now I have access to the course. So if I go to the dashboard here, I will have all the courses that I acquired before, and this is the one that I just acquired, so I will go here. This is the same page that we saw before, but now if I go to a lesson, I have the access to the YouTube video and I can see the lessons of that course. Again, this dashboard links is going to be only displayed for logged in users. So if I log out here, I don't see the dashboard link anymore, and I have the login link here. And if I go to any course, as I'm not logged in, I will have to log in first to be able to acquire the course. So this is like the application working. What I wanted to show you now is how to create an Auth0 application and how to configure that application from Auth0 in our web application to connect to that. I will go to auth0.com, which is Auth0 homepage. And I will log in because I already have an account, but you can create one. It's free and you only have to define some details. And now I will be redirected to the control panel. So now that I'm here, I already have an application created. So I will go to applications here. If you don't have one, you can create an application from here. And here I have all the applications from my account. I will see this one, Next Prisma Auth 0, which is the example that we are using now. And you will see here that I have this domain, which is one of the environmental variables that I mentioned you that you will have to configure. I have a client ID and a client secret that I can copy. And all these three details, I will have to use them in my web application configuration to connect to Auth 0. Then if we go here, we can see that we can configure a lot of things like the application logo. I used Auth 0, but we can change it. The application type that we are creating, this is like a regular web application. The authentication method that you want to use, etc. But one important thing that we have to configure are the callback URLs for a web application. As I'm using it locally, the callback application, the callback URL will be the one that is automatically generated by Auth 0 SDK, which is API auth callback. So I configured this one here. And you have allowed logout URLs, and I put the URL that you will be returning when you are logging out, which is the home page of my application, again, locally, because that is how I'm working. These fields are lists, so you can add other URLs if you want to use any other. And this will be all the basic information and configuration that we need for Auth 0 to be connected to our web application. Pretty simple. And if you are not, if you don't have more than 7,000 active users in your application, this is all you need to do, and it's free and you don't have to pay anything. But now what I wanted to see is the code of our application. So, well, this is the details that I mentioned that we will need to configure here with the base URL, the user base URL, which is the domain that we grabbed from Auth 0 control panel, the client ID and the secret for this specific application. Then what I wanted to show you is if we go here, this is a Next.js application, but if I go to the package JSON, you will see that I already added the npm package Auth 0. I hope you can see it. It's pretty big, but Auth 0 Next.js Auth 0. This is the SDK that I mentioned before. Here we have the root app file for our Next.js application. This is a file that will wrap all the pages from our web application. And something cool that I wanted to show you is that we have this user provider here that we are importing from the SDK. And user provider is a component that we can use to extend and manage a user that is logged in and user information in our web application. So if we want to access to information related to the user that is logged in our web application, we can use the component. So as this app file is the one that wraps all the pages from our web application, we are wrapping all the content with a user provider component. So this is accessible from any page from our web app. And here is the dynamic API route that I mentioned before. In the folder API auth 0 into the brackets, we create this file and we are importing these methods from Auth 0 SDK. The most important one is this handle auth, which is the one that will be in charge of handling all the authentication for a web application. So you can add the code for this method, default handle auth, without using anything from here. I mean, this could be like this, and it will work anyway without having to configure anything. I'm adding this piece of code because I'm using this handle callback function, because what I'm going to do is, as I want to link the users from Auth0 with the Prisma database, I want to call a function whenever I'm redirecting to the callback URL. So if I'm logging a user in Auth0, and I want, when we bring the user back to our web application, we are redirecting the user to the callback URL. But after this callback, this is the function that we are calling. After this callback, we will call a handle callback function that will be in charge of call this other function after callback, and this function will be executed before redirecting the user to our callback URL that we defined before. And this after callback function, what we'll do is to call this create user function that we are importing from a utility file that we have in our application. What this does is to create the user in the database using Prisma if we don't have that user in our database. As we have a unique rule defined in our database. If the user already exists, we won't create it again. But this is a handler function that we can see. I mean, it's we are instantiating a new Prisma client, and using the client Prisma, we will create a new user using the email that we are sending as the parameter to the function. We are getting the session, I mean the user that is logged in. We will grab the user object and grab the email data from here, because that is the property that we want to store. And this is it. This is all of what we need to handle authentication in our web application. What we can do now is add behavior to our pages to use this information. So this is like the API route that we would use to authenticate the users. But for instance, if we go to this page, which is the get button that we click when we want to get a course that we didn't acquire before, look that this is a dynamic API route, API get, and we will have a course ID, which is passed as a parameter through the URL. We will have this get session function that we are importing from the SDK. And when this route is executed, we will get the course ID from the URL. We will call that get session function that will return the user that is logged in our web application. And what we are doing here is instantiating a Prisma client that will update a user in the database, in our database, not Auth0, and where the email is equal to the email of the user that is logged in our web application, we will connect the course that we are trying to get. So this is the button get in the course page that we saw before. Another interesting page that we can see to verify how we are handling the authentication is the dashboard page. So I will go to Pages, Dashboard, and remember that this dashboard is only visible but for login users. So we will have the same get session function that we used before to get all the information related to the login user. And we will have a with page auth require function. So here is the code of our dashboard where we are listing all the courses that we have for the user that is logged in, all the available courses, and links to the courses pages. This is like the markup that we are generating for the dashboard. But when we execute this page, we will execute server-side code, first wrapping that with this function with page auth require, which means that if a user tries to access to this URL, to this page, we will force the user to log in first if the user is not logged in. So we will verify that only logged in users can access to this page, which is what we want to do. I mean, we only display the dashboard for logged in users. And after we verify that, what we do is to get the session, in this request, get the session, and we will get the user, and we will use the email of the user that is logged in to find that user with the Prisma client and include all the courses that we have for that user. And we will return from the server side, we will return a DB user object with all the properties for that user. And that is what we are using to generate the markup. We are using the courses list, and we are displaying all of them in the dashboard. And probably another cool component that we can see is the navigation bar that we have in all the pages, because you remember that we are displaying a login link or a logout link, depending on the state of the user, and we are showing or hiding the dashboard link if the user is logged in or not. So to do that, in a client side, we will have a React router, a React hook that we can use is use user, and we are importing it from Auth0 SDK too. And we get the user that is logged in now, and we can use that user. So if we have a user, I mean, if the user is not null, we will display the link to the dashboard. If the user is not present, we will return null and we won't render anything. And the same here. If we have a logged in user, we will display the logout link, which is, if you see here, it's pointing to an API route that is automatically generated by the SDK. I mean, this route and this file doesn't exist in our application. I mean, in our solution, in our file system. And if the user is not logged in, we will display the login link with the same logic, a page that is automatically generated by Auth0 SDK. So this is pretty much what I wanted to show you. I mean, the authentication part of the application is pretty simpler to implement, and you can use the information related to the login user in the client side, in the server side of our sites, and we have available different functions that we can use to make our work easier. This application is stored in my GitHub account, so if you want to take a look, I will share the GitHub link so you can see all the other pages in case that you want. And also, I will share with you these links. If you want to learn more, the official documentation site from Auth0, all the SDKs library that we have available in case we are working with a different programming language or a different tool or framework. You can see all the SDKs available there. And if you want to learn more about Next.js SDK from Auth0, that is the URL of the official GitHub repository. So you can see there all the functions, all the methods, and all the objects that we have available to be used in our Next.js applications. So that was it. Thank you very much for the opportunity again. And if you have any question, you can reach me. Those are my contact channel, let's say. And I hope you enjoyed the presentation. So thank you very much.
Awesome talk, Facundo.
Thank you. Thank you very much.
I should also say we have James Quick, who's a developer advocate at Auth0, part of is joining in the stream. Yes.
So cool.
Yes,
Thank you for joining.
Yes, I haven't really touched authentication a lot, but your talk was really insightful. Yes.
Thank you. Thank you.
And it seems we don't have any questions from the chat. So thank you and have a great day.
Thank you. Thank you very much for the opportunity.
Okay, bye. Cool. So I'd like to remind you about our raffle. To participate, you can simply fill out the form that we will also share again in the chat. You get a chance to win a copy of Designing Data-Intensive Applications by Martin Kleppmann. So our next speaker today is Jim Walker. He is the VP of Product Marketing at Cockroach Labs. He is also a recovering developer turned into a product marketer and has spent his career in emerging tech. He believes that product marketing is one of the most strategic functions in early stage companies and helps organizations translate complex concepts into compelling and effective core narrative and marketing strategies. So let's welcome Jim on the stage. Hi, Jim.
Hello, Alex. How are you today?
I am doing great. Are you ready?
Yes, I am. And do I still have it? It's about 25, 30 minutes, something like this, Alex. I just want to make sure I'm doing it right. So I set my timer correct.
Yes. Yes.
Okay, great.
Cool.
All right. Well, let me share a screen here.
Awesome. So whenever you're ready, adding it to the stream, and the stage is all yours.
Wonderful. I have the dual monitor thing going, so if there are any questions along the way, please do participate. But thank you, Alex, for the very kind intro, and thank you to the Prisma team. I am actually a where's my it was out of sync. Yeah, I am a developer turned marketer. I haven't coded in a while though, but I gotta tell you, I loved it, and I still kind of stay very, very close to really highly technical companies. I currently work at Cockroach Labs, but I'm a huge fan of Prisma, and I'm just very excited that I am finally on a meetup. I first met Johannes and Soren, years ago, and I've always been excited about what's been going on with this company. So, guys, I'm really excited to be part of this community and to participate here today. Facundo, I loved your presentation. This is going to be a little bit more academic as opposed to hands-on. But what I want to talk to everybody about today is to really kind of give a little bit of a dive into, Cockroach DB in particular, but hopefully use this as a context to go through some of the kind of the distributed concepts that are in Cockroach. I'll talk about the Raft algorithm. Hopefully we get to MVCC, which is multi-version concurrency controls. And so this is a little bit more academic, but I hopefully helpful. Now, please do, by all means, ask questions along the way. I am trying to monitor any questions that come up as well. And I'm fine being interrupted. And if y'all want to just send me questions, I hopefully can answer them. I should be able to answer them. So, all right. So about 30 minutes, 25 minutes, we will do this. We got a fair amount, and I hope it is helpful for everybody. So just to set the stage, first of all, there's these concepts of cloud native, and, you hear all these different things. To me, cloud native and this kind of move towards these kind of orchestrated systems really comes back to distributed systems. And, I'm a big fan of distributed systems and kind of where things are going. And more importantly, I've been in data and databases and data technology for really quite some time. And I'm watching a lot of data technologies move to the cloud. But when they move to the cloud, this kind of, lift and shift, they kind of land in this new infrastructure, and they kind of weren't built for that. Or even if you kind of move and improve whatever it is you built, it just doesn't work. Like, to really fully take advantage of like cloud and distributed kind of technology and infrastructure, you kind of got to build from the ground up and be cloud native. And I think that's where I see, everything new. In my opinion, most of the new apps are kind of going down this concept of distributed systems, and how do we think about, services in a way that are correct and are gonna keep data correct and these sort of things. And so, from Cockroach, we think of this as distributed SQL because it's a database that sits underneath kind of one of these distributed systems. That if you're going to build distributed compute and have microservices, all these things, then the database should kind of align with that. And so, to be distributed SQL, a SQL database, well, first of all, it's got to speak SQL. It's got to ease scale, right? A core principle of kind of distributed systems is work scale into your code, not around it, right? Don't use external systems. And also work resilience into your code, not around it, right? Build it into the system itself. Make it naturally resilient and naturally scalable. But if we're going to do this, for us, it was all about, doing ACID compliant distributed transactions at scale. With serializable isolation was our choice. But then also being able to tie data to a location is a critical concept to think about, not just within a database, but in everything we do distributed. We used to think of just data in a single data center or in a single kind of node or whatever it is. And, we think of the logical model, my tables, my rows, my objects and mapping to those and all that, and referential integrity. And, that's all incredibly important. That's like bullet 1. Bullet 5 is all about, you have to overlay the physical model on data as well, because 2 things. Number 1, the speed of light is no joke. You can't get past the speed of light. If we could, this would be an interesting world. I don't think I'm going to see that in my lifetime, but we'll see. But also it gets really important as our applications and services get deployed in a more complex environment of global regulation, and where data lives becomes something that's really important. For us, and I believe for distributed systems, you need to work that into the system itself as well. Don't rely on external things or the best practice within your development streams to say, hey, data that comes from Germany needs to live on German servers. What are you going to do that in where are you going to do that, right? And let's leave the database to actually take care of those things. And so for me, when I think about distributed SQL and this kind of emergence of this kind of new brand of database, this is what this is all about. Now, before I get into how we did this, just really quickly, Cockroach is a relational database. It speaks standard familiar SQL. This is wire compatible with Postgres. We've built ORMs that are integrated, that work with Cockroach. So there's lots of stuff out there. I know we're working deeply with the Prisma team. And so this is kind of something you're just already familiar with. It's just under the covers. It's very, very different, right? Because we actually have architecture for scale. You simply spin up a node, point it at the cluster, and you have scale. You have this horizontal scale. No need to do manual sharding. No need to deal with all these kind of complex operations to get scale. We can even scale even further beyond a single data center. We could scale into multiple regions, which is something that's pretty difficult, right? Because now you're dealing with networks, you're dealing with security problems, and the database just handles this. We can deploy a cluster of Cockroach across multiple different regions, and it's going to function as a single logical database, so that you can ask any node for the data, and you're still going to get that data back. This could even be multi-cloud. We have several instances of Cockroach that is a region just a region within a single cloud provider, or is it multiple different cloud providers? And maybe it's on-prem. And so, but still having a single logical database across all of this really simplifies, the management and kind of how we think of these things. Typically, we would just have done like some weird asynchronous replication between all these different environments. The database just takes care of all of that. I'm going to show you how that works in a couple minutes. And then it's naturally resilient. We can actually survive the failure of a node, a rack, an AZ, a region, a Kubernetes cluster, if you will. And it's just naturally resilient. We'll dive into this as well. But being able to survive that and still have access to data no matter what happens, this kind of eliminates the need of these active passive systems. Cockroach is an active database. And I think when we think about how we develop and architect our services, think active. I think is just another core thing to think about when we design and build. Now, I touched on something that was kind of cool. In Cockroach, we actually can tie data to a location. So you'll see, here's 3 records. Say they're customer records. I have copies of these things, because when I write into Cockroach, I write things in triplicate. I have 1 copy in US East. I have 1 copy and 2 copies in Region 3, which is EMEA. But if I access that data from, say, the West Coast, Region 1, US West, I can ask any node for the data. And every node in Cockroach is a single consistent gateway to the entirety of the database. Every node is an endpoint, and every node can service reads and writes. So I can ask a node, and it just knows where to find it. The cluster is smart enough to actually find that data. Now we do this because, well, you want to be able to access data, but we're actually geo-partitioning. We're taking data and putting it close to the user, because you'll see this user is Kimball. He's accessing his data. That's our CEO, Spencer, right? And that data is closer to them. So that's how we fight the speed of light. Because if I had to go from Germany or say Portugal all the way over to, the West Coast of the United States is at 230, 250 milliseconds one way, and then back another 250, 500, what do our round trip times start being? And really anything over 100 milliseconds, I think it's humans can identify a lag. And so how do we actually work that out of the system? Cockroach would be taking care of those things. So that's great. So that's how Cockroach is at the top level. Let me just go into a little bit how this actually works underneath the covers. Let's tear it apart. Now, there is some work here that's been built by some amazing engineers. I am honored and fortunate to work at Cockroach. I really feel lucky in many of my conversations, because some of the stuff that we're doing here is some really amazing software engineering. And, our three founders, Peter Mattis, Spencer Kimball, and Ben Darnell, all of them, early days Google, I think they were all within that 300 employee range, early days. And, and they sat beside and worked along with, the Jeff Dean and Sanjay Gemawat and Eric Brewer and the people at Google who have really kind of changed the way we think about systems and data at scale. And I think if I look at all the technology that's out there, some of these things that have happened in these large, web scale companies, especially Google, we're seeing this stuff kind of take hold and now be commoditized out for everybody to work on. And I think that's what this is. And so a lot of the concepts here come from the Google Cloud Spanner. So they have an internal database, a relational database that is distributed. If you ever want to read a cool paper, it's a great paper to read. There's a lot of great publications on the Google publication site. Some really cool things, MapReduce, Big Tables, the beginning of NoSQL, Spanner for this distributed SQL category, all the TensorFlow stuff. But these there's some really, really great innovation and a lot of stuff. I would be remiss if I didn't say, thank you to a whole world of people who worked on some really, really cool stuff here. So, all right, so how does this work underneath the covers? Well, any database is really can be broken down into, I like to think of it as 3 layers, right? There is the language, which honestly, if it's a database, I just feel that, SQL is kind of, you can't get away without doing SQL. Like, and for us, yeah, we chose to be wire compatible with Postgres. So the SQL syntax is the language. And then there's an execution layer, right? That's where all the magic happens and we do reads and writes. And then there's a storage layer, because ultimately the database writes data to disk, right? And building a database is sounds simple when I break it down into 3 layers, but it's just simply not. There's another kind of luminary in the database space, a guy by the name of Michael Stonebreaker, who actually won the Turing Award a couple years back. It's just brilliant. Stonebreaker said it takes about 7 to 8 years for a database to fully gestate and be kind of, reliable. And I love it because it's all the weird corner cases in a database that'll kill you. If it was easy to build a database, we'd all do it, right? Like why not just make that part of my app itself? And so it's just simply not, because there's so much that happens. And so underneath the Cockroach, we're building a database, but as a distributed system. And so we chose to be SQL. Now, ultimately, when we store data, we're actually using KV at the lowest layer. At the storage layer, we built a new database there. It's actually a database on top of a database. We built a database called Pebble. Pebble is a kind of a rewrite of RocksDB, and we wrote it in Go because all of Cockroach is actually written in Go. The code base is all available on our Git repo if you're interested. But ultimately, every table is written to disk as kind of monolithic logical key space, right? So the dogs table has, these, 12 records, and they're just they're ordered, see, right? C, D, F, J, right? And so everything is kind of ordered lexicographically. Now, an old database, like the traditional relational database, is, if we had an inventory table, we had glove, ball, shirt, shoes, bat, shoes. We would just keep appending records to a table, right? Just in order, in storage, just keep appending records. And then we use an index to find these things. at the the most generic level, that's kind of how the storage layer and how we actually access data in a relational table, right? Now, Cockroach, we're doing something different. We actually use KV, and KV allows us to do some really cool things. It allows us to get really, really fast. We have some really powerful primitives in a KV store that we can actually use. But ultimately, when we store data, the K in the KV is the table name, the index for that particular table, the key, and then a column name, and then the value is the value of that column. Now, all of this is encoded into the key. It isn't written exactly like this, so we get, huge, massive efficiencies when we sort and do some really interesting things here. And I'll show you how that actually helps us. But all tables have to have a primary key because it's part of the K and the KV. Now, if we were to take this table here, this is the dogs table with an ID and a weight added to it, right? And it's a pretty simple table and SQL syntax, right? The DDL's that. Great, I have this nice table. Now, how do I translate that to KV? At the simplest layer, it's pretty simple. What we're doing is we take the first column here and we say, okay, great. It's going to actually be the first row, and this is going to actually end up being two rows in our KV when we store it. Table name, the key, the column name, and then the value is Carl, right? And so that record was broken down into two, and we keep doing this. And so if you look at the sort here, right, the sort is really brilliant, right? We have the table name and then the key and then these columns. And so everything is going to be sorted and stacked. So now when we insert, we know exactly where to insert. When we start to do things like range scans, we can take advantage of this KV range scans, right? And so there's some really kind of interesting things that we can do that, but that's the magic of how we actually can turn relational into KV and then KV back into relational at the lowest layer of what Cockroach is doing, right? And so I think some really interesting things here. I when I explain this to salespeople and other people, I just bring up like an Excel spreadsheet and I show how you can sort and all these different things. But it's pretty cool because I'm going to sort within dog table, and then you can imagine another table after that. It's maybe it's ferrets or something, and then everything's going to be in order, and that's going to come back because I'm going to talk about how we actually can tie data to a location. We're going to use this concept, right? So everything is this monolithic key space, right? And then what we do is we take each table and we're going to break it down into ranges. You could think of a range as a shard or a tablet. What we do is we call them ranges. It's a 512 megabit range, right? And so contains X amount of records depending on the table itself. But these things are small enough so that we can move them around pretty easily, and we can do things like splitting them. And so this is how we get away with scaling the database without ever having, you never have to worry about sharding. We could actually collapse ranges together, and we could expand them. So what happens when we have these ranges? Well, you also need an index structure to find these ranges because they're going to be distributed across multiple different places. And so this is, if you're familiar with what a B tree is, it's very much like a B tree. That's kind of how we implemented that, right? And so now we can find these ranges. Now, it allows us to do these kind of cool, quick range scans. But when I want to insert a record, well, I go through this index. I find where, if I want to insert Sunny into this table, right? I know where to insert it. And so I come down, I ask this range, hey, is there enough space? Yes, it seems like there's an open space here. Great. Let's insert Sunny. Wonderful. Great. That's nothing has happened, right? Well, what happens when the range is full? Now I want to insert another record into this. Well, the database is smart enough to take that range and split it and now insert that record so that it now has space. I have just sharded the database. I just created a new shard without anything ever happening to the user. Now, again, say over time, records get deleted, we'll actually compact these things as well. But this is one of the magical areas of Cockroach that I found kind of really, really interesting. Now, if you think about this is the automation and the working of scale into the system itself. Right, thinking about how we actually do this across multiple different services gets really, really complex. And I think that's where the beauty of some of the more complex concepts in distributed systems really kind of help us think about how we scale and build resilience into our system. So now in Cockroach, we also use something called Raft. If you're not familiar with Raft, go check it out. I'll give a link at the end of this little section on where to go. Raft is a distributed consensus algorithm. It really allows us to provide atomic writes and consistent reads. Now, okay, so what does that mean? Well, Raft is really implemented as there's this concept of a replica set in Raft, right? And if you think about that blue range, what was it? I guess what was it? It was Lady, Lula, Muddy, and Petey. I think that's blue. I don't know, I'm a little colorblind. Well, when we write to a system and we write this data, we're actually going to write it in triplicate. And what Raft does is it manages sets of these replicas, these replica sets of data, right? So it's the same data across all three of these replicas. In this case, I have 3. It could be 5, it could be 7, it could be 9, it could be an odd number. We'll come back to that. But it's a real chatty protocol, and it basically keeps everything aligned, right? And these Raft groups is really kind of the magic here. Now, within each Raft group, there is a leader. And the leader basically is kind of like the authoritative source. It is always right. And then there's followers that always keep up with this authoritative leader, right? And then only that leader can serve up the most up-to-date information, right? Now I have 3 copies of this data. You can kind of go where we're going. This is where we're going to actually use this to store data within physical nodes, right? And then basically what it does is also delivers this atomic replication. So when we write, basically the Raft leader is in charge of making sure that the data is going to be correct across all 3 replicas. So it's going to implement something called a quorum write, so that 2 of 3 of the nodes, 2 of 3 of the replicas actually have to commit that data. And then we're actually say, great, we're good. The third one, if it's out of sync, it will always come back and always be in sync, okay? So we're using Raft extensively here. It's a pretty powerful implementation of Raft in Go. Actually, we actually contribute upstream. If you're familiar with etcd, which is kind of a core component of Kubernetes and whatnot, we actually presume that up. But if you go to this website, Secret Lives of Data, there's a much deeper explanation of Raft and how it works. I think they do a great job. I put lots of people there. So, but Raft is kind of one of these really interesting protocols and an algorithm that I think is, one of these more advanced algorithms that's really starting to drive the way we think about how we architect systems and how we think about data in our systems. Now, we do this in our database, but I think it's actually, there's a lot to learn here for everybody in terms of, these distributed principles. And that's why I like going through the architecture of Cockroach, because I think it opens up the minds of some of the things, the different ways that we do things, right? Like I said, Facundo was more like, hands-on. This is a little bit more academic, okay? All right, so we then use Raft to do how we distribute data physically within these things. And by the way, if there are questions, I am actually monitoring. I hope I can see the questions if they come up, the live stream as well. So I have a second monitor here going. So where do we place replicas? Where do we place these replicas, right? I have these 3 replicas in a Raft group. I want to place them in different ways because I want to do things like scale. I want to survive, right? And so there's lots of different ways we do this, right? And so typically for us, people think about failure domains. What do I want to survive? Or they want to even out data, right? And so each Raft group here, what I'm going to do is I'm going to take this first range, the first 512 megabits, and I'm going to write it to 3 physical nodes. These are 3 physical Cockroach nodes that are all functioning as a single logical database, right? And so I'm going to write the first Raft group across 3 nodes. I'm going to start the second one. I'm going to write the third one. I have evenly distributed this data across 4 nodes. Now, if a node goes down, I still have access to that data. I have 2 or 3 of the replicas left. I'm guaranteed that I'm still going to be able to write and read that data, right? But we also do things like, you want to distribute data based on load, say like maybe this middle range here is being accessed a whole lot. We use heuristics, with the transactions to actually understand that. So we separate that data out on its own nodes so that we can actually optimize the compute that it's running on, right? And so the database is smart enough to actually do that, to really kind of optimize, performance and whatnot, using heuristics of the queries that are going on at any particular moment. Now, we can also do something really cool, like we can actually geo-partition data, which just means basically we can take data and tie it to a location. Do you remember earlier when I had the K and the KV? Well, we had table name, we had key, we had the column name. Well, what if we actually added in a country code to that, right? Well, then everything in that ordered pair, in that ordered kind of lexicographical set, would be ordered. It would now have this country code in there. So like you would imagine EU and Carl, EU and Lula. And so now everything is ordered. Now when I split up my ranges, everything is mixed up, but it's actually split by a country code. So I can use a column in each row to actually change the sort of the lexicographic sort of the KV. And now I can be assured that, well, all these ranges, oh, this is a little bit wrong. These colors here are a little bit off. This first range is going to be written to, the EU nodes. The second range, I can actually create rules that this is going to be written to the east and then to the west. And it's really a simple couple, 4 DDL kind of statements that allow you to do this in Cockroach. And if you actually do it, this can all happen in production, right? So all this, as a distributed system is, right? So that's how we actually do that. So that's kind of a really special thing that we're doing in Cockroach about how we actually can tie data to location. Okay. All right. So we can also rebalance replicas. So how do we scale? Well, I simply add a new node I point a new node, I spin it up, point at the cluster. The database is smart enough to actually, I have free space. Let's evenly build things out. I can survive the failure. Oh, look at 2 of my replicas are gone. The RAF leader is smart enough to understand that, oh gosh, I have to create new copies on other machines. If the RAF leader goes away, the 2 surviving replicas, the followers, will actually nominate a new one. There's a RAF leader nomination process, which actually is pretty cool. And then we can actually survive these little small failures as well. Okay. All right. So about 10 more minutes left. And yeah, this is going to work. I definitely can get through the last bit here. I know it's a lot. I'm talking a little fast, but again, if there's any comments, good, bad, clarification, gosh, by all means, please do reach out and let me know. Okay. All right. So transactions in a database, it's all about ACID, right? Atomicity, consistency, isolation, and durability. We spent a lot of time at Cockroach thinking about isolation. We wanted to build a database that was not only going to kind of fight the speed of light, but would also be optimized on transactional consistency. A lot of developers don't think about isolation levels in a database, which I think is actually, I was a hack. I didn't think a whole lot about these things a whole lot. But now that I kind of know the things that can go wrong with data, the hacks that can happen in your system, the security holes they cause, having a database that's non-repeatable read or these other kind of isolation levels actually is tricky, and there's trade-offs of performance versus isolation and guaranteed correctness. And so I think it's kind of one of these things that I like to talk about a lot. And so at Cockroach, we've actually implemented serializable isolation, which means basically every transaction is going to be run in order, or apparently going to look as if it runs in order. And that is really basically the top level. This isn't like a NoSQL database. I know there was like somebody used Mongo. Like you can't get this level of isolation in something that's like a NoSQL database. The data model and the way that things work underneath are actually really too difficult to actually overlay transactions on top of. So you'll get like eventually consistent, but you won't get like guaranteed, 100% consistent, right? And so it's kind of one of those special things about Cockroach, but pegging out on isolation level the furthest we can go, and then fighting the speed of light all at the same time has forced us to do some really, really interesting software engineering. If you want to actually dive into the stuff that I'm going through here in more depth, I think our docs do a great job of talking about this stuff. I always give kudos to our docs team because it's just truly amazing some of the stuff they built. And I learned from there. And actually, we published a SIGMOD paper about a year ago, maybe now. Gosh, man, time flies. And that SIGMOD paper actually goes into detail a lot more of what's going on. So, all right. So actually, somebody asked a question. I have 3 locations. Thank you, Thomas. One has limited connection bandwidth. Is this harming general latency? That is a great question, Thomas. So say you have 3 nodes, you have 3 locations. Maybe you have 3 nodes in 3 locations, and I have this, this weird kind of connection between one of them. It depends on what latency you're looking for, because honestly, if we actually locate all the data for the transactions that are going to happen in that region into those 3 nodes or into that one, into that area, well, I'm going to get fast read write access in that region. Now, what if, I'm just arbitrary and putting things across and I access from one region into the next? It could have issues because you have this kind of latency thing. But what's interesting is you want the raft leader, that authoritative source, to follow the user. And we do things in Cockroach to actually help make that happen. So really, Thomas, it really depends on what you want to optimize for. Do you want to optimize for latency, or do you want to optimize for resiliency? And Cockroach gives you all the knobs and the dials to actually figure that out. And it's really down to the row level. It could be the table level or even the row level. It's not the whole database. It is really kind of something you think about, at the data at the row level, which is kind of a really key thing there. So, all right, so transactions. So I want to insert these 2 records into this table, into the dogs table. I'm going to basically start. Ooh, where's my mouse? Here we go. All right, so I'm going to start this transaction. I'm going to ask any node. Remember, any node is an endpoint, right? So any node is a gateway, and I'm just going to, so it's green. I'm just going to say, okay, great. I'm going to start. Now we create basically a special record within this range, which basically says I have a transaction that's pending. There's some system records that we actually use within each one of these to actually do this. And I'm just going to go out to my followers. I'm going to say, hey, create a temporary record here and insert it. And then as soon as one of those followers come back and I get acknowledgement, I now have 2 of 3 of my replicas are confirmed. I'm going to be good. I can go on to the next record, right? And I'm going to now insert Ozzy. This does the same thing. As soon as I get one back, great, I have 2 of 3. Now I can basically say, look at all these markers, these kind of temporary records that are back. I've got basically across all of the steps in my transaction, right? Because every SQL query gets broken down into this, amazing set of transactional steps, right? Now that I got this, and then when I go to commit, the commit says, great, go out and clear everything out, make everything confirmed, and send acknowledgement back to the requesting application. Now that seems pretty simple. Now, lots of things can go wrong here. And that's where I think the tricky part of Cockroach and a lot of stuff that we did, which is really, really, truly special. Doing this in a distributed system is also, a challenge as well. But this is kind of really how that works. And we do a lot of things under the covers to actually make this happen. Now, one of the things we have implemented is we've implemented MVCC, which is multi-version concurrency control. Another really interesting algorithm that allows for transactions so that there's going to be no overlap in transactions. Now, I'm going to go through, listen, I'm the marketer, right? But I'm just going to go through a top-level description of how this works. Actually, if you go to the Wikipedia article on MVCC, I found it to be pretty awesome. It's a pretty good description of what this is. But basically, there's kind of 3 things involved here. We have something we want to do with the data, the transaction. We have a timestamp for that transactions. And then there's this object or a row of data that we want to actually, affect, right? And so what we do is that for a simple transaction, we just start off at time 0. We have this transaction that wants to happen. We communicate the write over to the object. The object now has 2 timestamps. It has a read timestamp and a write timestamp. We increment the write timestamp to be what was the moment that actually happened. We create a temporary object, and in this temporary object, we're actually going to change the state, and it's going to come back, and everything looks good. And that took 2 seconds. And so now what I've done, when the temporary object actually commits, basically it says everything's good. It comes back and it says, hey, look at the time between the read and the write was 2 seconds. So update my read timestamp to 3. Now I know basically that when the last write came in and when the last commit actually happened on each object. Okay, so that's a simple flow. Let's try it again with a conflict, right? Transaction comes in, I do the write, my write timestamp went up, I go write the other temp object, and in the between me writing that other temp object and basically me updating that read timestamp, it kind of getting committed on the second object, another write is coming. And this timestamp now, timestamp 2 is 02. It's at 2 seconds in. Well, what it does, it says, hey, wait a second. My timestamp is greater than the read timestamp. So I have a conflict. I have to deal with this now. I have to resolve this. Now, the database is just taking care of this in the background. But this is kind of one of those things, as you have distributed systems and you have, multiple different requesters asking another object for something, MVCC is great for a database, but MVCC might be very interesting in the way that you implement a consistency for your transactions as well. I think this is a really, really important algorithm to understand. But this whole the timestamp, the read and the write, that's the basics of it. Gosh, I just explained it pretty simply as a marketing guy, but there's a whole lot of complexity there. Now, what we have to do with Cockroach, and when you use Cockroach, well, you're going to have to wrapper your transactions with a try catch block, because this stuff happens. Because you have, people all over the planet and thousands and hundreds of thousands of transactions going against the database at any moment. And so this kind of stuff actually becomes pretty important. So long story short, MVC just allows you basically every transaction is going to happen like you're standing in line. Next, right? Like single teller, right? So, Okay, so I think, you know what, I am at the bottom of my time, so I'm not going to go through any of the other stuff that I have here, but I will tell you, we have some great coursework in Cockroach. There's free university. We'll give you free swag for all this, and then if you want to actually go try Cockroach, there is Cockroach Cloud as well. So that was a fair amount in 30 minutes. I believe I was right there at 30 minutes. So Alex, thank you. And if there's any questions, gosh, by all means, please feel free to reach out to me. And then I'm also, I'm just at James, Jaymce on Twitter. I mean, almost everywhere. James at Gmail. I think I've consolidated all over the place on that. So Alex, that's I just wanted to thank everybody. That's the end of my presentation.
Awesome. I enjoyed the talk and I learned a whole bunch of stuff. It seems that developer tools keep getting better and better, including databases. I just learned about MVCC. I hope I don't forget that. I only have one question though. Is there sort of a performance issue when you're translating a request or a query from SQL to KV and then SQL again? Perhaps.
Yeah. So we aren't really, I mean, yes, right. Like there is this concept of like, if it's a straight transaction going, we actually gain a whole lot in translating to KV at the storage layer. It ends up being, it ends up being faster because the way that we access data, we don't have to always go through the index, right? We don't have to go through this complex index process of like where it actually gets stored. We're using KV, and the primitives of KV, like the get and the put, which are like, that's why people invented KV databases, right? Because they were so fast, right? We aren't using pointers at the bottom layer to actually go out and get the storage. Now look at Oracle and Postgres, these things, man, that layer is so incredibly optimized because it's been around for 15, 20, 40 years, it's really, really fast. That's not the areas that we're worried about latency. That's the stuff that's kind of simple and straightforward for us. For us, latency is raft. When I have to write to two nodes, like I think Thomas's question, it's related to that. When I have to get quorum and two replicas are in different, like one is in Sydney and one is in New York. That's the stuff that gets really interesting. And we've done some really interesting software engineering, something called parallel commits, which, we can't change the speed of light, but we can change the photons that are going over. That's the way I like to explain it, right? And so we could forward commit a transaction on one node, look at the picture of it around it, send that to the next node, and it'll just look at the picture around everything and say, hey, look I am pretty sure this thing is going to commit to 5 nines. Great. Just send back an acknowledgement that I'm going to commit. Like we've done some really interesting things from a software engineering point of view to kind of fight the speed of light latency. That's the one that we're most worried about, Alex.
Awesome. Thank you. Also, before you leave, share the link in the chat so that we can also post it to our audience.
Yeah, you bet. I'll get the slides to you. So I hope that was helpful. Thank you.
It was, and thank you again for being part of the meetup. Awesome.
Yeah, I bet.
Okay, now we are on the final leg of our meetup. Next one, we have a back-to-back presentation by Martina and Nilu from our team. Martina writes documentation for developers, switches between dark mode and light mode at random in every app to keep things exciting. In previous careers, she has been a front-end developer, a .NET dev consultant, and a build server goblin. And she looks forward to the day when a database cartoonist becomes an essential job. I think this is sort of already coming to life, given that she's at Prisma and makes a lot of cartoons as well. And she'll be presenting with Nilu, who builds websites and apps and loves experimenting with new UI libraries. She moved to Berlin about 5 years ago and has been trying to learn the basics of the language ever since. So let's welcome Martina and Nilu. Hey, everyone.
Hello, everybody.
Hello. Hey.
Are you ready to present?
Yeah.
It's you first, isn't it, Nilu?
Yeah, I'll share my screen. Sharing. Okay. Yeah, here it is.
Awesome. And then I will leave you to it.
Okay. Martina, you can start.
Yes. So hello there. Nilu and Martina here. We're going to talk about building and writing the Prisma documentation. Starting with Nilu, who's going to introduce herself first of all and talk about building the docs. Yes, building our docs website.
Definitely. Thanks, Martina. And thanks, Alex, for the warm welcome. Hello, everyone. My name is Nilufar Bava, but I know it might be a bit hard for you to pronounce, but you can call me Nilu. I joined Prisma last year in March 2020 as a web developer, and I've been responsible for the development of all the static web pages that you see on the web related to Prisma. Not all the static web pages on the web. This includes the Prisma homepage, the Prisma with X pages, the data guide, the blog, and the docs pages. Currently, I work in between having to deal with a tantrum-throwing teenager, or after the terrible twos, it's threes. So if you have any tips on dealing with that, or if you need any more information about me or my work at Prisma, you can contact me in the following handles. Now, so when I said I joined as a developer, what I really mean is that I'm just the only female developer in the web dev team. So that's why you can call me or the team as a one-woman web dev team. Wonderful name. Building the docs is an ongoing project with a huge number of components and functionality. It keeps changing and being updated all the time. But for this particular talk, I'll manage to cover these following topics. Framework selection and why I chose Gatsby over Next.js, the folder structure for the docs repo, the custom MDX and plugins we have created, the search functionality in indexing, code highlighting, and we've done a huge UX revamp a few months ago. Then as a bonus topic, I'll just give you a brief idea about our design system, which is called Prisma Lens. Now, when I joined, the first responsibility I was given was to build the Prisma Docs 2.0, which needed a whole array of improvisations over the Prisma 1 docs. So even though the Prisma 1 docs was written in Next.js, I went for Gatsby here. I know there are a lot of Next.js fans there, and you might be wondering why I chose Gatsby over Next.js, but I'll just give you an idea why. The doc writers wanted a better performing, a smooth live editing support, and support for large number of MDX files. And they needed better SSD support than, so last year, definitely Gatsby was the choice for SSD when I started the docs project. Then we have better MDX support with Gatsby, and the data fetching was much simpler using GraphQL in Gatsby. But above all, the main reason was because I was more comfortable with Gatsby than Next.js. Might not be the reason now when I want to start the docs. I may choose Next.js. Who knows? So if you want to check it out, the Prisma Docs is available in Prisma.io /docs, and the public it's a public open source GitHub repo, so you can find that in github.com Prisma /docs. Now, this is how the docs look like. In case you haven't already seen, you might have already. So we have a home page now, and we have the individual pages with these layout. As you can see, I'll explain more about this later on. Now, the folder structure. So about the folder structure, as you can see, there are a few Gatsby related stuff. The Gatsby browser, JS, Gatsby config for all the plugin configurations, then Gatsby node for the API generation, APIs for the page generation logic. Then we have the SRC folder, which contains all our React logic components, the hooks, the layout stuff. Then we have the content folder, which hosts the MDX files used by or written by the doc writers. The functions and Prisma folder, as you can see, are the ones, these two folders is for the feedback component, which you can see in the pages. This shows that we are using Prisma in our own docs project, and it is a prime location if you want to check out an example. So yeah, so this is basically the folder structure. Now for the MDX pages, we structure the MDX pages as folders and files which are numbered. so that the doc writing team can maintain the ordering of the files using these numbers. And now during the build process, we strip the files of these numbers and make sure the URL does not contain these while still maintaining the order. So you do not see the URLs when you are going to the page. You do not see the numbers in the URL. Sorry, this is done. This stripping of numbers is done in Gatsby Node.js file during page generation. Now for the custom MDX components, the MDX there are a lot of a variety of components which comes out of the box from MDX, but still our doc writers are not super happy with whatever they have. So we are always giving into their requests for new and complicated components, and now they are very happy. So we have a huge collection of really cool MDX components. You can check out these the code for these in the components bar custom MDX folder. And if you want to check out how it looks like, we have a page in the docs website. It's called under the Prisma style guide, the MDX components. So we have all the sample components listed here. Now about the custom Gatsby plugins. The config contains all the Gatsby plugins that we use, which is available already from Gatsby. But there are times when the available plugins are not enough for our usage. So we have created a few plugins for the doc specific functions. So we have the Gatsby plugin page list plugin, basically for SEO purposes. Then there is the remark check links numberless. This is for the link checker to strip the numbers and report the broken links according to that. And then there is the remark to absolute URL plugin, which converts these relative URLs to absolute ones so that the doc writer doesn't have to concentrate or bother about such things. Now, as your docs grow, you might have to get creative and need more plugins and incorporate into this folder. Now, let's move to another important topic, which is how we implement the search and indexing. We have a React component dedicated to this, which uses Algolia library under the hood. Upon searching, like if you click on search, the bar, the hits or results are displayed in such a way. Like on an overlay with all the list and the maximum 20 items are displayed in one go. Each record in this index or in our Algolia index contains one heading, the paragraph which it refers to, the URL to the link, URL to link to, like when you click on that, which page or which section to open to, and an ID to identify between these. Now, as mentioned, we use Algolia, which delivers real-time results from the first keystroke. So it is very fast. For Algolia usage with Gatsby, we have to use a plugin called as Gatsby plugin Algolia, and we achieve the functionality using the React version of Algolia's instant search library, which is the React Instant Search DOM. The indexing method and how we did it can be found in src utils Algolia.js file. So what we do here is we use the row body field from the GraphQL node for indexing, and we strip it of all the unwanted MDX stuff, and we create one record in the index. Now, a very important topic which everyone wants to know about is about code highlighting. So we have different sorts of code highlighting here. You can see examples of this in almost every doc page. We have both code highlighting, like normal code highlighting, and highlighting specific lines and line ranges. So you can see how code addition, deletion, and special editing, and other sort of editing. So we have different sorts of highlighting lines, and we have code for all this in the code highlighting component. So we use Prism.js and Prism React renderer libraries, some formidable labs for achieving this code highlighting. Since there is no language support for Prisma language in Prism.js yet, we have also created our own custom language support for Prisma lang. And this is what you can see in the previous slide, the model which we have created, that is Prisma language. And we also have custom light and dark themes for code highlighting. So we use the dark themes mainly for indicating command prompt. So as you can see how we are indicating the npx Prisma command prompt code, that is the dark theme. So we have both in the Prisma doc. Now for the UX revamp. We had an old design and we did a huge design revamp on our docs website a few months back. And the result was hugely, like appreciated. This is how the old design looked like. Here, the TOC or the table of contents was placed at the top of each page, and scrolling down removed this from the view as well. So you cannot come back to the TOC unless you go to the top of the page. And there were also some quick links provided at the top of the navigation. Now, the new design looks something like this, and it's improved the UX to a much better extent because of a number of factors. There was a whole new homepage for docs, and this provided a well-needed starting point. Like we needed a homepage or a starting point for docs, and a place to quickly guide the users to the main aspects of the docs. We also introduced a concept of buckets, which are like the second header you can see in the light gray. So we grouped similar content into buckets and placed them as a second header under the main quick links header. So this made finding content much easier. As for the individual pages in the docs, this was much better organized than before as well. And we have two separate sections, the sidebar and the TOC at two sides. And both of them are sticky now and follows you as you scroll. And this made reading the content easier. Overall, we managed to improve the ease of usage, the performance, and accessibility in this new version. Now, moving on to a bonus topic, which I would love to cover. This is our design system, Prisma Lens. This is also open source. You can check it out in the public repo, which I have provided. This is a design system that is basically guidelines and component library for the family of Prisma projects and products. So this means that all the user-facing products and web pages of Prisma uses UI components from this design library. So it has a theme file which contains specifications for all the colors we use, all the radii, the spaces or margins, paddings, and basically the font sizes, everything. So this follows the system UI theme specification. It's highly atomic. All the components are very low level, and we are still working on this. It's still a work in progress, but you can check out the storybook integration for this in the prismalens.netlify.app, and you can play around with the components. So this is something which we are really proud of. So you should really check this out. Now, if you want to know more about any of these topics in detail, please let us know, and you can contact me as well. Now, I will hand it over to Martina. She's a very witty doc writer to explain more about the process of writing our docs. Martina?
Sorry, I was double muted. Hello, I'm just going to share my screen and then talk about filling this lovely website you've built with content. So just 1 second, Alex. How are we looking?
Yeah.
Ah, perfect. All right. Thank you so much, Nilu, and hello, everyone. I'm here to talk to you about the writing process here at Prisma. My name is Martina. I am a confusingly titled education engineer, but I spend most of my time writing docs. You can find out more about me on Twitter or GitHub. And I'll start off by saying that I'm not the only one who writes docs at Prisma anymore. We now have a dedicated documentation team. And it's currently made up of 2 lovely people who look like this. There is myself, a Swedish person in Denmark who joined in, a bit too fast there, who joined in 2020, April. And there is Rich, who is a Brit in Sweden, who joined in March 2021, so this year. And apart from the 2 of us, there are also other people with slightly more normal-looking feet who contribute, like the DevRel department and the engineering teams as well. Everyone on the doc team currently is a former developer who decided to take off their developer hat and instead put on the very fancy documentation writing pantaloons, very high fashion and comfortable. So we're developers who decided that we'd rather be writing and sometimes regret that choice a little bit. So what do we do all day in our very cool pantaloons? Well, like all writers, we spend a lot of time crying and crying and staring into space, because you need a certain amount of drama to be a writer. But at some point, we also fit in our documentation writing responsibilities, which are highlighted here. So we are responsible for documenting new features, creating realistic examples, explaining concept like what's a schema, how on earth do the connectors work. We write guides that put Prisma into context, like how do you deal with connection management with Prisma? How do you test it? How do you deploy? We maintain the API reference, and of course, we iterate and improve constantly on everything we've written. We manage your feedback and PRs, and sometimes, like now, we do presentation videos and cartoons. And often we are the first users of a new feature outside of the engineering teams, so unintended QAs that break things. So in short, it helps to be a Jacqueline or Jack of all trades when you are writing documentation. Let's talk about the writing process. So Nilu's already talked a little bit about, or a lot about our website, but the things you really need to have in your backpack when you're writing is a familiarity with Markdown. I never remember how to put in images, so I have to Google that every time. We tend to use Visual Studio Code here. We use a lot of custom MDX components, and we manage everything in GitHub. And it also helps to have a spare pair of pantaloons and a very strong Pokemon, but I think that really applies to life. So armed with these tools, there's 4 steps really to writing documentation. The first is that you need to be a little bit like Varys from Game of Thrones. And if you haven't watched Game of Thrones, Varys is also known as the Spider. He sort of knows everything that's going on all the time, and he's always listening. And it helps to be a little bit of a weird stalker spider person when you're writing docs, because input from docs can really come from anywhere. So here I am as a spider, very pretty. It comes from the PMs or the developers telling you, hey, we've built something we need to document. You might stumble across a small feature whilst just testing the dev distribution tag. I spend a lot of time trawling through commits and issues and tests and PRs, because the developers scurry around and leave little nuggets of wisdom in there sometimes. Internal Slack, because we're a remote first company, is full of information, particularly around why we've decided to build a certain thing a certain way. That's really, really important. And we also learn from your real world struggles that you post on Twitter or Prisma, GitHub, or in the external Slack as well. So we're driven by what you talk about. And then finally, there's the common problems in the ORM and database spaces, like N+1 with GraphQL or skip take pagination in databases. So we try to preempt people having issues with these things by writing docs. So you've been a stalker, you've been a spider, you've kept an eye on everything. The next step is to do some deep research. And this is my favorite, because this is where you really realize you're getting paid to learn things and then write about them, which is wonderful. So you might spend your days in this kind of environment, very familiar if you're a developer, building a POC, writing examples, asking a million questions of the eternally patient engineering teams, bless you and thank you. Research broader topics. I recently had to become an expert on JSON path, which hurt a little bit, and connection limits in Postgres, which hurt even more. You start to think of yourself as a bit of an expert. You start to volunteer to present at conferences. You regret everything, and then you repeat it. This is all part of the research process. But one of my favorite parts is when I get to break stuff. If I manage to find a bug or a use case that hasn't been considered in one of the tests, I feel like I am giving back to the teams that are helping me to understand a new feature or a new concept. And I hope that they appreciate it too. So after you've spent a few days in research mode, like really marinating, you actually have to write something down. And this is the hard part. This is the stage where the majority of the crying inevitably occurs. So to help you not suffer as much as I do when I try to write, I have some tips on how to write good documentation, or rather what I think matters. And my tips are, to avoid, first of all, to avoid walls of text where it's just Shakespearean prose, where it's very hard to pick out, does this piece of text answer my question or not? I would break it up with examples, tables, lists, diagrams, to make it a little bit more interesting, because often people are coming to the docs in anger. They have a job to do. They just want an answer to their question. They don't want to hear how smart I think I am. And I did a history degree, so I love writing, flowery prose, but that's not for the doc world. The second related point is to make your docs scannable. And that means separating the key points out into headings so that you can link to them. And if I scan through the doc in 10 seconds, I can quickly answer, is this document going to answer my question and make my day today? Write for an international audience and make no assumptions. So you can probably make the assumption that people are familiar with TypeScript and maybe a little bit databases, but try to pitch everything at a level where a seasoned individual knows how to skip through it and someone who's just starting out gets help. And make sure you don't use any jargon or slang or Latin, because it's not accessible to people who maybe juggle 4 languages on a daily basis. And finally, don't forget the search engines. And the thing that we spend most time doing is splitting very large pages into smaller ones, so that when the Prisma docs come up in Google search, people can immediately tell that, yes, this is a page for me, rather than say our CRUD page at the moment is a bit long. So you can't really tell if your question about deleting many records is there or not. So that's a to-do. So once you've suffered through the writing process, oh yes, I forgot to mention actually, there is a lot of really good discussions on Twitter about what makes good documentation. This woman has loads of replies to her question, and if you're interested in docs and improving yours, I'd recommend checking it out. So you've suffered through the writing process. The next step is to review. We review our docs in the same way as we review code. We create a pull request, and then we ask engineering or product or DevRel or whoever has the expertise to have a look. And again, very grateful to everyone who spends the time. Reviewing is a tough job, and thank you. Finally, you merge and marvel at your gorgeous content. And then you repeat that process forever, and I hope not too much of it is spent crying. At some point, though, you need to stop and try to measure your success. Your docs are live, but are those magical pantaloons actually doing anything for you, or are you kidding yourself? And the one thing I want to say about measuring success in docs is that it is difficult. Analytics can be misleading. You might see someone spending 5 minutes on your page, and that might either mean that they are loving it, or they cannot find an answer to their question. So it's pretty difficult. We like to monitor support questions. So after we've written a dense topic, check and see if the amount of questions on a specific area are going down or up. Where there's also a thumbs up and thumbs down widget on the site that we consult sometimes, but that might either tell you that a feature is confusing or that the docs are bad or good. It's kind of hard to know. And we also appreciate people who raise issues on social media, either issues or if you're happy with the docs, that's always great to hear. Yes, and in future, we're hoping to do slightly more advanced testing of our docs to figure out if we're hitting the spot. And again, some great conversations on Twitter about measuring success in documentation that I think you should check out if you're interested. And that, folks, is how to be a writer. To round off this presentation, I would like to just let you know again that, as Linda mentioned, Prisma's docs are open source. We very much appreciate it when people take the time to raise a PR, raise an issue. You can do that on GitHub. So I look forward to encountering you in spider mode on the old internet. Thank you very much.
Awesome. Thank you for the presentation. It was really insightful. I do have to say that I appreciate anyone working on any documentation because docs are hard. I remember working on a page last year on Sequelize, and it was a little bit painful. Yeah, I remember. And also feels like there's a lot of intersection between docs and DevRel as well. Yes.
It's a lot of crying, Alex, honestly. It's hard work.
Yeah. Yes. Any input from you, Nilu? I think I appreciate the components. I think there are things that I never think of, or we just find ourselves taking for granted. Yes.
Mm-hmm. Yeah, I mean, it's like I said, it's a very vast topic. Like you can't just cover it in such a short time. But if anybody needs to know anything more, or if you have any doubt or any problems with what I have already discussed, you can always contact me, like I said. Yeah.
Awesome, thank you. Rich is also in the comments, and people are showing a lot of appreciation for the docs and your presentation as well. Yes,
Thank you.
thank you.
Thank you all.
See you on Slack. Yeah.
Bye, everybody. Thank you.
Bye, and thanks, everyone.
Okay, it's the final bit of the presentation. Moment. So, I would also like to say that recently, Dr. Stephen Jensen published a course called End-to-End React with Prisma 2 on Udemy. It's completely free of charge, and you can get access to it by using the code end-to-end June 2, sorry. It will be active for the next 3 days, and we'll drop the link in the YouTube chat shortly. And lastly, we recently announced the third edition of Prisma Day, which is a 2-day community-focused online conference for modern application development and databases. You can sign up already and stay up to date and by going to prisma.io/day, and we'll drop the link for that as well in the YouTube chat. So thank you everyone for attending. The winner of the raffle is Ransford Arthur. We will reach out to you after this meetup. Yes. Thank you all. Thanks for joining us. Till next time.